Check. Mic check. Can you hear me? All right. Starting recording. All right, everybody. Welcome to the second last session of the day. Everybody's back from a break. I hope you're all awake and alive. And if you're not, we're going to talk about issues in the network, and I'm sure that's going to wake you up. I'm Vinny. I'm a product manager with Microsoft, working with Azure Networking, working with network monitoring. With me, I have Shivani, who will talk about network monitoring. And then we will have Dallin, who will talk about monitoring your workload end to end. And that will include all flavors of your workload. Please put up your hands if you have any questions, and the mic will come to you, and you can ask your question. And we're also going to be available post this session for you to catch us in case you have any other questions. And we'll be happy to respond to that as well. So quickly getting started, we will start like you all start. We have Ali, who works for Contoso, and she's thinking of migrating her application. And she decides to go to Azure and take up AKS as her top choice for deploying her workload. And when she sort of gets started, like all of us who are getting started on this journey and we don't know how to get started, she looks for an AKS baseline architecture readily available in Microsoft documentation. She picks that up and she starts her journey of preparing the cluster, building the network, deploying the cluster, deploying the workload, validating it, and then going live. Now let's see how Ali goes through the motions. Now she starts by understanding the cluster, what she needs to sort of create it. She understands what access she needs, her subscriptions, AD access. She then thinks very smartly about ensuring that the cluster is secure. It should have minimum admin privileges. She decides the capacity, she decides how to deploy it, what she wants to connect it to, all of that, and she moves on. She comes to the target network. Now, this is where she's thinking of an architecture, she's thinking of isolating the network, thinking of what to expose to the internet, and Shivani is going to talk about the rest of it.
Check. Okay, so coming, okay, I'm audible. So coming into to build target network, this is the most crucial part of any architecture deployment because this is the backbone. Based on this, whether it's scalability, whether it's extensibility, how things would plan out, it's more like a foundation blueprint that you put before starting your house, right? So on that, Ali looks through different design consideration. She wants her architecture to be scalable and extensible. So as her organization grows tomorrow, it takes care of the new features. She wants to obviously segregate the subscriptions, so not everybody has access to everything. Only limited access is provided to the people who really needs it. Again, there is always a like in this era, always it's good to secure, minimum exposure to the public internet. And obviously cost is a big thing, correct? So can she reuse most of the component so that things are under the budget? So she evaluated different design models, and from there she chooses to go through hub and spoke model. Let's see. Oh, I'm sorry. Okay, I think. Aisha. So Hub VNet is a central point of connectivity and observability along with segregated management. So here, as you can see in the highlighted box, the Azure Firewall, Azure Bastion, and Gateway, which will be commonly used across different spokes, are clubbed together in the hub. Also, Azure Firewall, again, this as it's clubbed together, it also helps with cost optimization. Again, if you talk about Azure Firewall, it helps at ensuring that both inbound and outbound traffic adheres to the organizational policies. Coming to Azure Bastion, it ensures that all the access to the workload compute is secure. And our gateway ensure that connectivity across on-premise to Azure is both seamless and secure. Moving ahead, coming to the spoke VNet, where she would be deploying her workload. Again, here this is an interesting bit because here this gives Ali the autonomy to segregate based both on workload type as well as her different department organization. Maybe she would want to just provide it for another spoke for say DevOps, another spoke for HR, based on the organizational need. Again, because she is going to deploy the AKS cluster, she needs to look and consider different posture for cluster networking. First one is control plane networking. Control plane networking is basically how does your cluster communicates to your API server. There are multiple, obviously there are mainly two options for her. One is public cluster and the other one being private cluster. Also, there is one other feature that is in preview is the API server VNet integration, through which Ali can seamlessly transition from public to private clusters. Coming to node networking basically talks how your cluster access the public internet. There are multiple options: load balancer, NAT gateway, user-defined routing. And again, these these are in itself broad topics, but at a high level, Microsoft does recommend soft load balancer as a preferred choice. But based on your outbound connectivity, for a large outbound connectivity, NAT gateway would be a preferred choice. Also, if you have some certain organizational rules which wants the traffic to move through Azure Firewall and NVA, you know the answer is user-defined routing. Coming to pod networking is more like how pod communicates to each other. And does it need to have a direct pod IP access or a publicly accessible IP? So there are two flavors to it. One is overlay model and flat model. The recommendation and the most popular one is the Azure CNI overlay model, where the customer does not need, or Ali does not need to think about the IP allocation. It's basically a separate IP, separate private logical IP allocated to the node and pods, and it's separate from the VNet where the AKS node is existing. And then there is a flat model where the option is pod subnet and node subnet, where basically things would be, the IP would be allocated from the same AKS node where the VNet is. So with this, I'll hand over the stage. Okay, there is also, I would want to make an announcement on configure static egress gateway. So with this release, you can ensure that your traffic goes through a dedicated gateway node pool, which is the static egress gateway. It is basically you can define your source IP. Through a predefined source IPs, you can ensure that traffic is going, your outbound IPs are communicating to the external services. This gives you more granular control over the security and your seamless interaction with external services. With this, I'll hand over my stage back to Vinny for management story.
All right. That was fast. And we have a question, please. Hold on. I will pass the mic to you so that your question gets recorded for the record.
Okay, when you say static egress gateway, right? So you secure an IP. Let's say for ingress, you secure an IP, right? And when you, let's say, redeploy, I mean, you are deploying it again, right? So does the static IP stay, or how do you manage the static IP?
I think we will check and get back to you. It's a slightly technical
Okay.
thing, and
Okay.
we need to understand where the IP is coming from, how's the nature of the IP that you've deployed, how you set up the static. So we'll talk
Yeah,
at
sure,
length about
sure.
it, and we'll get.
Sure, thank you.
Okay. All right. Okay. So what did we do? We looked at the architecture, we decided the cluster, we went deep into the cluster, we understood the networking of it, and now we've decided to deploy it. We already know what it contains. And what happens after this? Your workload's gone to the cluster, you're ready to go live. And this is, in a sense, what you have created in the last 5 minutes. It's a large topology which connects you to on-premises, which connects your users to your workloads, which is sitting in the spoke VNet. And now what does Ali do? Ali has set up this whole system, so she validates it, and she is good to go. But is that what happens in reality, right? Have you ever troubleshooted any issue in your workload? Or is that what you do all day long? Based on the questions that I hear from you all, I think observability is something that all of us are sort of keenly looking into. Once we go live, we don't always stay live, and the rest of the story is going to talk about that. So first up, how do we look at monitoring, right? if your workload starts from an on-premises system, sits inside Azure, is getting access through internal systems like any tier 1 business application, or is getting accessed by your end users and sort of directly over the internet, sort of those clusters are speaking to your end users directly, we visualize the entire architecture into two parts. One is connectivity to the cluster, and then we speak of monitoring that connectivity to the cluster, which in most common cases come from on-premises. And second, we look at monitoring what is inside the cluster. And this talks about everything that is your nodes and your pools and all the various cool features that are in it. Three teams come together to make this happen. So you have Network Watcher, which gives you observability to the cluster. You have Azure Monitor, which sort of gives you visibility into Prometheus data. You have ACNS, which sort of gives you networking related specific stuff. All of this is readily available in Azure Monitor for you to consume. With that, I'm going to talk about the first piece of observability, which is connecting to the cluster. A typical hybrid application, your on-premise is connected to your Azure cluster via an express route or a dedicated connection. You have different flavors of monitoring. Each of these resources sends its performance and health data into Azure Monitor, and you can set alerts, and you can look at the performance metrics, and you can find out what's going on with these resources. That's more of a white box approach when you actually know the resources that make your network. And the second is when you sort of treat it like a black box and say, I want end-to-end loss and latency data from the start to the finish. And that is where connection monitor in the network monitoring suite comes into play, which gives you loss, latency, and topology using synthetic probing from your on-premises to Azure and back. Now, when you've detected that something's up, troubleshooting tools like packet capture and connection troubleshoot, etc., come into play, which gives you deeper insights into what could be sort of wrong in your system. All this data goes and sits in Network Watcher. That is one of our dashboards for our system admins, for the network admins. Data is also available in Azure Monitor. So you go to the network tab and you will see another dashboard which will help you correlate data with your developer observability. That was sitting outside the cluster and connecting to the cluster. Looking deeper inside the cluster, we start with Azure Container Networking Service. A lot of you are familiar with this solution. This is providing you visibility inside the Azure cluster. This supports both Cilium and non-Cilium Linux data planes. And all this is integrated with Azure Monitor so that irrespective of what your role is, you could just go to Azure Monitor and get a good sense of what your workload is looking like, what is the health of it, and you can use that as a starting point for troubleshooting any issues. Switching paces and talking about full stack observability within the cluster, handing over to Dallin.
Hey folks, I'm here to talk about full stack monitoring on AKS. I want to talk about how Azure Monitor, which is our core product, brings you the best of open source as well as Microsoft's tooling to help you monitor your workloads on AKS. So as you spoke about, after you take up all this trouble of setting up the network, running your applications, inevitably sometime or the other, you're going to have an issue where your workload is not working out. You're facing issues, it's not live, there is issue in production, and you want to go and start debugging what happened there. This is where our Azure Monitor suite comes in. It has multiple components. Now, typically when you think of monitoring, you have your usual components, metrics, alerts, logs, and traces. Now, we think of metrics and alerts as your solutions to detect the issue, and logs, events, and traces as your way to diagnose and resolve the issue towards the end. So now when it comes to metrics and alerts, our core product is the managed Prometheus offering. It is a highly scalable managed database offering for storing metrics data. For alerts, we have Azure Alerts for logs and Prometheus Alerts for metrics. Finally, closing the loop, for logs from your application, we have App Insights, and for logs from your infrastructure, we have Container Insights. And for traces, we have Application Insights again as well. So I'll talk more in depth, but this is the high-level offering in terms of the core monitoring tenets. Now there are various layers and roles in Kubernetes. So now right from the network admin who has to handle the network, the components, the policies, to something like a platform developer who is more concerned about infra, node scalability, right up to the core application developer writing your business logic. As you can see, the managed service for Prometheus sort of scales up right from the network up to the application layer. It's a common sink for all telemetry from application as well as infra. Similarly, Container Insights is the source for all your logs from your infra components. For application data, we have for the L7 application layer, we have Application Insights. Now, one thing I want to highlight is that you have two options for visualization of your data. The Azure portal, which we natively support. Now, supporting open source, we also have the Azure Managed Grafana service, which works alongside. We generally keep these two visualization options at parity. So pretty much all the features, all the metrics options that are available in the Azure portal are also available in Azure Managed Grafana. And we respect the user's choice to choose either of these. Some customers are more open source heavy. They use Grafana and they want to use Azure Managed Grafana. Some customers just prefer to roll it along with the portal. So let's start with our metrics database, Azure Monitor Managed Service for Prometheus. Now, this is a fully managed offering. We have not taken open source Prometheus and tried to scale it up. In fact, at the backend, it is a proprietary Microsoft database that we've been running for 10 plus years, for which we've provided a Prometheus metrics compatible front end. How it works in AK is that you deploy the metrics add-on, and that enables the collection from your cluster. And a question from your cluster, we provide a lot of default out-of-box Cape configurations. You can not only collect data from your cluster, you can also use a remote write option. So you can forward data from your self-hosted Prometheus to our managed Prometheus as a backup. So, or if you feel that, okay, I only want to store a subset of my data in the long run in the cloud, you can use a remote write option. So it comes with an API and you can remote write data. And of course, you can use our add-on to get data from your cluster as well. Now, the most important point being that it is integrated out of box with Azure Managed Grafana, which means that when you turn on Managed Prometheus, a lot of dashboards in the Azure Managed Grafana solution light up by default. So we'll see more of these in the demo. Quick important point is that the default set of metrics that we configure, there's a default set of metrics we configure, which we call the minimum ingestion profile. This is meant to be lightweight and ensure that customers are not blindsided out of the box when they turn on Prometheus. However, you can add or remove sources based on your needs. So if you say you want networking, you will turn on ACNS. You do not want certain configurations, you can turn it off and reduce your sort of ingestion bill. Now, one announcement to today, we are announcing the CRD support in Managed Prometheus, which means you can write your own Managed Prometheus CRD. It takes the same schema as the open source Prometheus operator, and now you can treat it as a resource, put it into your automation, and build on top of it. We have pre-built integrations for Kafka, Elasticsearch, Argo, and many more are coming along the way. Yeah. I think they need a mic. Yeah.
Okay. When you said that from my open source Prometheus, I can write it to manage Prometheus, right?
Yeah.
So it's the data collection endpoint, right? Where I have to write it.
So there is a Prometheus endpoint where you can write it. Yeah, that's correct.
Okay, but it's giving me authentication error when I try to do that.
I mean, that would be specific to you. So I think the larger concept that's behind which the metrics are
what I did was I just created Prometheus workspace using AZ add-on command, right? So it created a workspace, it created a data collection endpoint, which is visible on the portal, okay, on the overview page. So I try to write metrics from outside of the cluster to that endpoint. So it gave me API authentication. So is there any way to, is there any flag or anything that needs to be added or authentication to be, just asking.
Yeah,
because
I don't think
it's a good use case in my project.
Yeah, it's definitely an authenticated endpoint. So I believe you'll have to make sure your API has the relevant keys before you, send the API calls. I mean, we can debug offline.
I can, yeah. Thank you.
Yeah, but that's the typical use case. If you want to forward data from your self-hosted Prometheus, you can use our API endpoint. Going forward, now just want to add, just as I was mentioning that customers have the option of using either the Azure portal or Grafana. So we recently added a unified monitoring dashboard to our Azure portal. So this shows you metrics not only from your cluster, but also managed resources like load balancers, SNAT ports, any of that. We are surfacing metrics in one place. This is very uncommon and typically customers miss issues that are in the underlying managed resources. I'll show more about this in the demo. Okay. As I mentioned, alerts are the next component typically you think about when you're in your monitoring journey. So now one great thing that we built is one-click recommended alerts. So instead of you wondering about, hey, which are the type of alerts that I should set up, you can see on the screen that we have these alerts that we have where we have predefined thresholds, predefined categories of errors. And in one click, you can use an action group and your alert will be configured for you. So, and they can be configured on logs, Prometheus metrics, platform metrics, activity logs, and more. Yeah. Now, coming to Container Insights. So folks who aren't familiar, so Container Insights is our log collection solution. It deploys the logs add-on to your cluster, and data from this goes to the log analytics database of Azure Monitor. Now, analytics again is our ultra powerful, logs database, very scalable, supports querying, joins, all of that. And Container Insights is a solution for collecting log data from your cluster. It supports collecting both, your standard error logs as well as control plane logs from your cluster. Another cool feature of Container Insights is that it has live logs. Once you enable the console in the portal, you can start streaming live errors from your cluster. Now, customers frequently, one issue that we hear is that, hey, I do not like the default set of logs that are there. I want to exclude a certain namespace. I want to turn off certain logs. The cost of logs is something that is frequently brought up. So one thing that we've worked on is the customizability of logs. So now we've made it very easy to exclude or include namespaces and turn off log collection. We also have various profiles, standard, developer, and more, which allow you to turn off various categories of logs. So say you do not want to collect syslogs, you can turn it off. And this is available both in the portal and through through your config map. So one new feature that we're announcing today is Kubernetes metadata. So one common request, especially in comparison with Grafana Loki that we got, was the ability to add annotations and have them be a part of the logs. So now going forward, annotations that you add to your logs, like pod labels, pod annotations, pod UID, image ID, etc. These all will be added to your container logs, and you can now filter based on them, scrape based on them, filter your errors accordingly. This makes it very powerful for you to isolate issues in your workloads, especially based on annotations if you had been using them in Kubernetes. And we have, and just as before, we have pre-built dashboards for these in Grafana as well as the portal. You can forward those dashboards and customize it as you want based on your needs. Finally, the last leg for application monitoring. So as Application Insights is Azure Monitor's solution for application monitoring. It allows you to just add your SDK to your code, and get a rich, powerful sense of how your application is performing. We start tracking your request. We allow you to trace your request across various microservices and understand how your application is performing. One powerful feature that we're going to announce soon is auto instrumentation. This allows you to auto instrument your application without doing any code changes. Essentially, what you do is just a configuration change, point your application to the Azure Monitor OpenTelemetry distro, and our instrumentation then get deployed in your cluster. And along with that, you start getting a service map of your applications call. So it is available for select languages currently, and this is going to be launched soon. One other important point in the world of application monitoring is support for OpenTelemetry. So how many of you are using or considered OpenTelemetry in your clusters? Okay, that's interesting. So it's something, a standard that's emerging, that's very widely supported in the industry, and Microsoft also is a big champion of it. So far, what we've done is we've wrapped around the OpenTelemetry SDK into what we call the Azure Monitor OpenTelemetry distro. So the distro not only uses the SDK, but it wraps it around and adds Azure Monitor specific features like live metrics. But that's not the only way customers want to use it. Some customers want to use the vanilla community SDK. That is the next milestone that we want to support, where you can use the vanilla OpenTelemetry SDK, that is path number 2, and hook it up to Azure Monitor Agent, and then write it to our ingestion endpoint. What we're also planning to support in the future is the OpenTelemetry collector. Now, it won't be exactly a Microsoft managed OpenTelemetry collector, but it'll be a product resembling that, and it's an optional product where you can use OTel collector equivalent functionality like processing, filtering, etc., and store it locally and then send it to a backend in Azure Monitor. So as you can see, we have plans to completely support the entire OTel ecosystem, all the components, SDKs, OTel collectors, etc., and make them work together with Azure Monitor as well as other destinations. So I'll pause here if there are any questions. Otherwise, I can head towards a demo over here.
Will Prometheus also be continued collecting that element? Like will Prometheus, the Azure managed Prometheus will also be continued because it is also collecting the telemetry?
Yeah, so you'll have the option of configuring it as per your needs. So if you feel that you want to send metrics to a different database or not use Azure Managed Prometheus, then you can use the hotel collector. But if you use Managed Prometheus, we will deploy our own metrics add-on and use it. Yeah.
Okay, thank you.
Yeah, but that product will remain live. That will be separate. Yeah. Okay, let's do a demo of this. So this is showing a Kubernetes cluster where all the workloads listed. This is service A, B, and C, which have been set up, as demos. As you can see, all of them are currently working fine. Services A, B, and C listed there. Now, just for tests, we do a few API calls. The first few work, and in a bit we'll notice an error. Okay, service B failed, propagating error. So how would we go about debugging this? So let's go on the journey with this. So first we'll go to the monitor tab, which is our new home for unified monitoring. As you can see here, right off the bat, we have a cluster summary. So it's showing me events at the top, and you can see a collection of cluster-related charts at the bottom. So there's nodes in the cluster, there is pods, namespaces, node CPU, node memory, logs by volume, all the typical things, all the typical metrics, and that you'd expect to understand the state of your cluster, including right down to networking, like packets dropped and received. Finally, I want to call your attention to AK's managed infra. So this is something new we are doing based on customer feedback, where you're bringing in metrics from a load balancer and OS, disk bandwidth, to help you understand what's happening in your cluster. So it could be a component outside your cluster as well that affects your application performance, and we want to highlight that here. Now let's go into the two fired alerts who are there. So here you can see these are two metrics-based alerts. You can see that's Prometheus recommended pod alerts that are firing. So this shows the process of setting up a recommended alerts. Just one click, you can select it. All of these are already enabled, but it's usually just one click to enable them. What happens when we look at an alert? So it tells me the exact error that's happening. So you can see kubepod container restart, which service is happening, and the control that caused the issue. Based on this, I can start debugging. I can search for these errors in the logs and start debugging this particular error and for this particular service. Now, since we know the error name, we can start going into the logs. So, yeah. So as would be a common workflow, you would take your error string and you'd paste it into your container logs, and you would start finding out, hey, which particular service, etc. Here is where the last announcement I mentioned comes into play, where if you have pod labels like annotations, pod annotations, they will help you debug which exact pod or which exact service was having an issue. I'll fast forward some of this. Another option that you have is, in case you don't catch the error in your cluster, is to use our diagnose and solve problems. So something that we're doing is we are trying to add monitoring also where customers go, which is in the support flow. And instead of customers having to look through monitoring dashboards only, we also add these relevant monitoring metrics to support flows like diagnose and solve. So here, the same monitoring data is telling you which exact pods were killed. It's giving you a complete report and telling you potential resolutions about how you can handle this memory, killed issue. So we have an entire suite of dashboards in Grafana. As I was mentioning, we try to build a parallel experience in both the Azure portal and Grafana, Azure Managed Grafana for customers. These dashboards are available out of box. You don't have to do anything to deploy them. So the moment you enable Managed Prometheus and you're collecting metrics, these dashboards light up, and you can start exploring the various, we have compute, network, application level dashboards. We also have full stack dashboards to help you narrow down your issues. So here we continue the journey. We start looking into networking issues. You'll start seeing very rich data about the state of networking in your cluster. So bytes in, bytes out. What are the drop reasons for various packet drops, etc. So Similarly, now continuing back to the application map. So if you have application insights enabled in your cluster, you get this very lovely visualization called the application map, which tells you which exact service is talking to the other services, and you can see where the errors occur. Now, not only can you see metadata about the applications, you can also see infra that is affected by it. So you can see the exact compute instances which are affected by a particular error, service names, most common errors. And finally, you can jump into the related infra for it. So you can jump into a relevant container and go and zoom in to see, okay, hey, this particular container on this particular node or this particular service, this was the amount of memory that was consumed, or this is the limit that has been crossed. So this is the overall picture of how Azure Monitor through Managed Prometheus application insights and container insights helps you, monitor your AKS clusters. Yeah, that's about it. Thank you. Yeah.
No questions? Thanks. Great. Hey everyone, Rajat and I will be going over some of the reliability best practices for AKS, specifically focused on disaster recovery, how you can use some of the AKS features like AKS Automatic, like deployment safeguards, and AKS Fleet to make sure that in case something does go wrong with your deployment, you're able to fail over and your application doesn't have any downtime. So when it comes to reliability, AKS is now a platform which is used by a lot of different customers, some who run just 2 nodes with a very small workload, but then you also have other customers who'll run 500 nodes with 100,000 pods. And the more customers grow, the more important reliability becomes. Any minute of downtime is going to cost a customer business. And none of us like that. We don't like it as AKS. You don't like it as a customer. So in order to provide a reliable, scalable, end-to-end platform for our customers, we take a 3-pillar approach. The first one is platform reliability. AKS is a managed platform. And what this means is that unlike vanilla Kubernetes, which you would have to manage everything for, we will manage the infrastructure under your application. That includes the control plane, where the API server and etcd is hosted. It includes the nodes where your application is running. And it also includes support for Azure features like availability zones and all the different regions available. This allows you to maximize availability by using all the resources Azure has to offer through your Kubernetes cluster. I'm going to cut this in half because I know we're towards the end of the day. So good news, because Karthik and everyone else have already spoken about upgrades, half of the application resiliency topics. We're going to skip over those, and we're going to focus a little bit more on platform reliability, and then Rajat is going to come join us in talking about backup and chaos testing. Now, before we dive into this, who here has been using Kubernetes for more than 2 years? Would you consider yourself to be Kubernetes experts? Mostly? So you would know that Kubernetes is fairly complex. You can kind of think about it as a 3D model that we have there on screen. You have different elements to it. You have things like number of nodes. You have things like number of pods. You have IP addresses to consider with networking. And the thing is, as you scale up in each of these directions, it's going to impact the other directions as well. What that means is, if at once you try to scale in all those directions, you're likely to break your cluster. Has it happened with any of you? Yeah? So keeping that into account, within AKS, we do make optimizations to help you scale your applications. So as an example, our clusters support up to 5,000 nodes. We have support for up to 2 lakh pods per cluster, and that's a fairly large amount. The strategy we use here is we want to do all of the performance and reliability improvements under the hood. We don't want it to be that you come to AKS, you deploy a cluster, and then you have to go ahead and enable 100 different settings. No one wants that. So the strategy we use is making all of the improvements that I mentioned on screen under the hood so that it's available to everyone by default. And we're not just stopping at these. We even have other improvements like API server tail latency reduction, which are coming in our future roadmap. And we're not just saying that as a marketing pitch. We're actually putting our own reputation behind it. As part of AKS's standard tier, we offer customers with a financially backed SLA where we guarantee availability for your cluster by telling you that, hey, if we break the thresholds mentioned on screen, we will refund the money to you for the downtime we caused. And because of how AKS is embedded into the Azure ecosystem, if you use availability zones, we provide you a higher guarantee compared to if you didn't. And again, if you break it, you're going to get your money back. And along with that, we're also making changes under the hood to improve scheduling in the Kubernetes layer by making changes such as changing the pod topology constraints, max Q value to 1. If you're one of the people who've been on Kubernetes a while, you're now thinking, okay, I'm zone resilient. Now I need to go multi-region. You can do it yourself. All of these different steps, you can stay up night after night and figure it all out. That's totally fine. But you're going to have to manage everything from each individual cluster, the load balancer in the front, the storage, the data replication. It's a lot of layers. And you can even have the traffic deploying across these clusters, active-active, active-passive. And we have a document which talks a little bit more about what these different approaches mean. But if you're not that kind of person, if you value sleep and you don't want to focus on all of this at once, we do offer a solution which is more managed called AKS Fleet Manager. And within Fleet Manager, you can use features like cluster resource placement, which allows you to spread your deployments across multiple clusters, allowing you to be resilient to any kind of issues in a specific region. You can manually or automatically fail over between clusters, depending on how you configure your application. If you have any questions on this, feel free to come stop me later today or even at the booth at KubeCon.
Is this applicable for public URLs or private endpoints as well?
Public, definitely. Let me confirm back to you about private. Apart from these, which are more to do with failovers and high availability in case something goes wrong, there are other reliability recommendations as well that we provide when it comes to actually running your cluster on a daily basis. That could include enabling some kind of auto scaling as cluster autoscaler, node auto provisioning, which uses Carpenter underneath, making sure you're using the latest generation of hardware like the V5 VM SKUs offered by Azure, making sure you're using a dedicated system node pool to make sure you don't have resource starvation for the system pods. There are a couple of other recommendations as well, and if you do all of these, you're less likely to have downtime. Now that was the platform itself, but the platform's not everything. You also have to take into consideration best practices when it comes to your application, as it was outlined by our speakers earlier. Rajat will come take over to talk a little bit more about how you can back up your data across regions and how you can test in case for failovers.
Thanks, Vaibhav. So I'll take you through how Azure Backup for AKS helps you out to achieve your data resiliency need. Kubernetes has always been a preferred workload for stateless applications, but with the arrival of CSI drivers, we are now seeing a push towards running Kubernetes for stateful. You're running your databases like MongoDB, RabbitMQ, Kafka, and all which you are running. You are running such kind of stateful workloads on your AKS clusters, and then it makes it mandatory for you to have such kind of a tool which can help you to achieve data resiliency. So Azure Backup for AKS comes out as a managed service for you. We package Valero and make it available for you. As in case you might have already have tried out your hands on using Valero in the market to achieve your backup needs, we decided that we will merge the goodness of Valero with the goodness of Azure Backup and bring in a combined solution for you for achieve data resiliency for AKS. It is aligned with the container storage interface, so you get Kubernetes aware backups And you get application consistent backups also if you are running databases like MongoDB and MySQL and all. At the end of it all, I'm also going to show you what enterprise grade features that Azure Backup brings to you, which allows you to achieve encryption, ransomware protection. You can fulfill your compliance needs and achieve a common mandatory 3-to-1 backup strategy that you have to have backup data stored offsite. A lot of features mentioned here. I'll just look at and take you through in terms of what your use cases are and where Azure Backup comes in handy. So you might have applications which might need to be backed up every 1 hour, every 4 hour, or daily basis. Azure Backups helps you out. You can set up your frequencies as per that and achieve backup. You want to retain data for 7 days or you want to retain data for 10 years. Azure Backup comes in again handy for you for your AKS clusters. The need might be that you need retain backups for deletion of accidental deletion of data, or there's a compliance need. You're working with a customer who, or you're building applications for markets where there are compliance requirements that mandate, let's say, to store data for 7 years or 5 years or 10 years. Backup comes in handy in those cases. You're running applications, but you know which specific components within your applications are to be backed up. You might be running a MySQL, you know this MySQL is important, I need to back it up. You might be running a Redis along with it, but you know that, okay, I can avoid backing it up. So Azure Backup gives you that fine-grained control to it. You can pick up particular namespaces so that you can define your application boundary for your backups. And then you can even use labels, so you can pick and choose specific resources within your cluster and back them up as per your needs. Now you might be running multi-tenanted applications, multiple departments of application running in same clusters or serving different customers, but same application for different customers. Backup again comes in handy because you can now define backups for your individual applications, create backups for specific application boundary as per the specific frequency or need that you have. You can achieve that. So that comes in handy with the cards. I mentioned about application consistency for backups. You're running databases, that becomes key. You do not want your backups to be crash consistent. You want them to be application consistent. You can achieve the same thing by just implementing backup hooks. Now, for cloud admins, in general for an AKS operator, but the moment a cloud admin comes in where you're looking at an overview across your cloud, how their backup stature looks like. You might be operating 50, 100 clusters. You want to see which are protected, how they are protected. Am I following, being compliant as per the standards that are being set? Are my applications running according to that? We have something called Azure Business Continuity Center, which acts as a single pane of glass view. How this single pane of glass view works, it's not just for your AKS, you are running your AKS with other Azure resources also. You might be running Postgres, you might be running SQL Server and all. Everything is covered within this single pane of glass view. You can take a look at it across your workloads, across your application and see how things look like. And then you get the basic features that are very essential. You need your alerting, you need your reporting, you need to show those reports to be compliant. Backup gives you handy for that. So all in all, your minutia needs that comes in with regards to your application boundary to a larger level compliance need that comes in, Azure Backup covers it end to end for you. Now, this is as I mentioned initially, we bring in compliance angle to backup also. Now you want to retain for 5 years. Usually backups on Kubernetes has always been snapshot based backups. You take a snapshot, you retain them. Snapshots are costly. There are issues that might come in. So we went and brought in aspect of Vault, where the idea is that backup data would not be retained as snapshot, but will also be stored outside of your tenant altogether in a concept called Vault that we have. This makes your backup much more secure. Now this backup data is not in a snapshot format, it's now stored as blobs. You can retain these blobs up to 10 years. Now it solves your problem. At max, majority of compliance regulations that you might be dealing with goes up to 10 years, so it solves that problem for you. Apart from that, you get a low cost storage tier. So now you're not storing in snapshots, you're storing in blobs, your cost automatically goes down. You can make those storage to be zonally redundant, geo redundant as per whatever that your needs are. So you can make your backups again to be more resilient. You get your data resiliency with backups, and then your backups can become additionally resilient with zone resiliency or geo resiliency comes in. I'm just gonna bring in another aspect that we brought in with this new release in Azure Backup for AKS. Now you can achieve something called disaster recovery for it also. specific category of applications that we are bringing in is for 24-hour kind of RPO that we call it as. Those are the applications that are supported with this current version that we have released. So any kind of a regional outage happens, your backups are available in another region, and you can bring them up to operate your application backup. Backup to be available, the SLA is 24 hours. So basically the SLA number is 24 hours, can be reduced also. It depends on the size of the data. We commit an SLA of 24, but we are working to bring it down to 1 hour also. Down the line, you will see and hear upcoming releases, which is intending to bring it down for you. Okay. I'm sure if this is going to be offsite. So the backup data, once it's stored in what the guys like a vault, the pricing actually is compared to lower if you are using backups as just as snapshots. Snapshots comes at a higher cost as compared to a blob-based backup. So you get in terms of storage cost that comes in is reduced. Now here you have geo-redundant backups. So you are basically having 2 backup copies. So you will be paying for 2 backups separately. But overall, in compared to snapshots, the costs are lower for you.
So I have an existing resource, and now I want to have geo-replication. So is that possible, or I have to destroy the resource and create?
No, you can enable it on the existing resource in itself.
Thank you.
Quick configuration, and your backups will be ready to be available in the other region.
Okay.
This comes in handy for stateless scenarios also, where you do not want to maintain like an active passive setup of running 2 clusters on both the regions. So you can utilize this capability to even apply disaster recovery for stateless clusters also. So as an example coming. And with this, finally, you've brought in cyber resiliency for your data also. So now you get ransomware protection. As I mentioned, the backup data is stored outside of your tenant in a concept called vault. Now, if your tenant itself goes out, your backup data is safe. So if subscription gets deleted, everything gets deleted, just your tenant exists, just the entry in the enterprise exists, you can still recover your backups and bring back your apps. So that makes it more secure. You get encryption on your backups. You can have your own key and encrypt your backup data. You got...
For Azure files, the UMI is still not, the managed identity is still not enabled. So we have to use the keys itself, CFK keys, right? But like Microsoft is enforcing to use UMIs, right? So it's been going on for a year or so. So is there any plan to, because
it's part of our plan to bring in support for UMIs also.
okay.
So down the line, coming months, you might be seeing something on this part. It's part of our.
Because we have been struggling with the applications. There are many applications. Right?
Yeah. So currently working on to enable that. User identity is a big push. As part of this feature, also you're gonna see user identity coming in.
Okay.
So you can use backups using your user identities.
All right. Okay. Cool. Yeah. Thank you.
You get effective RBAC control, so you can define which user within your subscription or tenant can access your backups. You can separation of duties that comes in as part of along with it. So you're an AKS operator and a backup manager can be 2 different people, and 2 different accesses can be managed for you. That
Thank you.
You get multi-user authorization, which is what specifically allows that if you're going to perform destructive operations, your backups, you're going to delete your backup data or something. An individual user cannot do it on their own. They need to go and get it approved by somebody else. This adds up additional layer of security for you. And at the end of it, you get soft delete. So even if your backup data gets deleted, we maintain your backup data for next 14 days also on your behalf. So even if usually it takes 2 weeks to recognize if such kind of an operation has happened, so we will maintain it for 14 days. You can even increase it to 90 days also as per your need. We have management level immutability today. So you can, if a backup has been defined that it needs to be retained for, let's say, 1 year, nobody can come in and delete that backup data till that retention duration is completed. We are in coming months going to make it worm immutable also. So underlying storage would have write once, read many. So not even just on a management level, but on the storage level itself, your backup data becomes much more robust and secure. So this is an all in all what we have recently brought in for Azure Backup for AKS in terms of what supports that we want to bring in. I have a quick demo just to to show you how you can enable all these resiliency features that I talked about and how you can do a disaster recovery kind of a scenario with Azure Backup for AKS. Okay, so scenario one, I'm going to start creating with what we call it as a backup vault. And I'm going to create this vault with all the essential security features that are needed. So quickly providing baseline details, name and all. So I'm enabling immutability, soft delete. As I mentioned, 14 days is default. You can increase it to 90 days. You can enable encryption here in itself as part of your backup creation. And you can enable disable if you want to allow restoration in a different subscription or region. So you get that level of control on your backups. So once Vault is created, now you can jump in and start backing up your EKS cluster. So this is our business continuity center, as I said. This is where the single pane of glass comes in. All the workloads that we support are visible on this center for you. So I'm going to start and select the Vault. Move forward, couple of quick validations. Going to select the cluster that I want to back up. This is I have. So now, as in case backup supports both public and private clusters, so any kind of a network configuration that you have, we can still back them up for you. Quickly defining a backup instance name. This is what you can use as an application boundary for your backup. And this is where you get the detailed list of filters that we provide for you. You can select namespaces, you can select labels and all what you want to do. Now, here your backup is configured. So this is called a backup instance in our term. Now, as per whatever the schedule that you have defined, will consistently keep on taking backups. But time to time, you might need to do your own backups also. So you can do ad hoc backup. Take an example, you are doing like a Kubernetes cluster upgrade, moving up your version. You might want to do a blue-green upgrade. Taking a backup gives you that confidence that, okay, everything that I had deployed earlier is safe and secure from my end. I can use it later on when I need it.
I had a question. So when we switch traffic for multi-region, when we switch traffic from one cluster to other cluster, I mean the region, right? Then how does AKS, I mean the application is deployed on AKS, right? How does the application knows it should write to the proper MySQL or PostgreSQL or whichever database, and how does that backup? Let's say I have switched my PostgreSQL as well.
You have switched your
right?
Postgres also along.
My AKS and the other resource also I have switched the traffic. So how does the backup understand that? Okay, I mean, how does first thing is PostgreSQL or MySQL understands? I mean, how does it takes a backup and how does the communication happen between those two?
For a database, usually when you have created a replica, there is an automated failover mechanism that exists. So it automatically transits your traffic from, let's say, region 1 to region 2 you have moved. It automatically starts. Once you have called it, it's a failover. It automatically, Azure takes care of traffic movement for you. Now with AKS context, let's say you have mentioned a database strings that are to be used specifically.
Right.
Now, I have backed up a YAML. What I do or taken as a backup is a exact YAML file that is there, that I have backed up and snapshots as in case comes in. What we provide to you is something called as a resource modifier. You can use that to define certain rules that, okay, I am using this database string. I want to change it when I'm going to restore to another region. So you can just define those rules. And at the time of the restore, we will do those changes appropriately for you.
So I have to do changes in my application.
You just know, you don't need to change it. You don't need, just need to write one script to us and give it to us. You have just to write a custom resource and give it to us. We will, as part of the restoration process, take a look at that custom resource, apply those rules on your YAMLs and do those changes. So take another example. You might using a standard SSD disk. You might want to move to a premium SSD disk. You're going to have to change the storage class.
Right.
And quickly do that. It's an example I'm giving.
Okay.
And say with that same with the database strings, you might be using static IPs you have put up within the
Right.
so you can do those changes. So any kind, and it doesn't constrain with the what components are immutable, what are mutable. In that case, because you are redeploying everything from the get-go start, all the changes with YAML changes things can be changed within the YAML.
Okay, got it, got it. Yeah, thank you.
So here, as in case while I was having conversation, we finished the entire end-to-end demo around on the structure on the backup product. That you took a backup, you moved it into the what we called as vault. It copied and made it available into another region, and then you performed a restore for you. So this is an end-to-end scenario that I covered for you, how you can create cyber resilient backups and then use it for regional resiliency scenario also. Now, ultimately, at the end of it all, when we talked about the entire resiliency components and all that are there, it's essential for you also to test your resiliency. So initially, Karthik also pointed out Azure Chaos Studio integration. You can utilize both Azure load testing and Azure Chaos Studio combined to check if your application that you have deployed can go through fault scenarios and all, which are pre-developed by Chaos Studio, and you can use load test to plan and define traffic that you want to, you test out your AKS cluster as according to that. So if you want, say, node outage scenario or a pod outage scenario, you can try out with Azure Chaos Studio. So you get that integration available. And we recommend that you do these resiliency testing so you are aware that, okay, these are the limits of my application, the way I have deployed, these are the limits that I'm working with.
So that was good. Yeah, thank you so much for attending. That was the last talk of the day. We can take questions now. For the previous question on private clusters, yes, Fleet does support private clusters as well. It's documented in our public documentation. So, if you have any other questions, so that is a load test. Yeah, so this is in Grafana. Yes. So this is in managed Grafana, but the load test is a different service in Azure. So you have to trigger from there. Like, are you asking if this is a pre-made template for the Grafana? No, this is not posted. So
No, the report which has been shown on the portal, right? The test execution report. Is that the same report that is running on the Grafana? Yeah, just previous frame. Yeah, this report. Is it the same report running on Grafana, the one which you are showing?
So the one in Grafana is from the application's perspective. This is from the load. So you have an external service which is triggering a load on your endpoint.
Right.
The one which had the white background, the one in the load test service was from the load test perspective, where it's telling you how many requests it's triggering and how many of them are failing.
Right.
This is from the application's perspective.
Okay, got it. The cluster.
Yeah. So this is just a quick demo of how you can use, this is to trigger a load, and then simultaneously if you use Chaos Studio to trigger a fault such as a node down or a networking fault, you can then correlate both of them to see how your cluster would respond.
See, I'm asking this question from the enterprise point of view. For certain, I know that I need 5 nodes to be running all the time, right? And how do I optimize that? I understand the scalability point, right? Scale in, scale out. But, if I think about this thing and if I think about the serverless architecture, so I just want to get out of this confusion that where cost would be less. Is there a concept of RI or something, where we know certainly that these nodes are required and I can do a RI, something like that?
Could you specify what does RIO mean? Reserve instance. So your question is that I have a couple of pods I want to run. I want to run the minimum required pods at any given point of time, which will optimize for cost in a way. So typically with Kubernetes, we recommend having a utilization on your nodes about 60%. Going above that can then go ahead and reduce your fault tolerance because then you're pushing your node to the limit all the time. So look at the request limits that you've set on your pod and calculate based on, okay, I have these many pods. These are the node taints. So I know that pod A, B, and C are going to go on node number one, and then calculate how much space you need on node number one to achieve 60% utilization consistently for those set of pods. So if you use taints and tolerances, requests and limits, you can manage to properly spread your pods across all the nodes. Apart from that, if you use node auto provisioner as well, which uses Carpenter, you can add some configurations around optimizing for. I can have one of our other PMs who works on NAP help answer some more questions on that. But you can optimize the scaling pattern a little bit to make it more cost sensitive, performance sensitive, etc. So I would say from the application point of view, set the right requests and limits, calculate it theoretically is fine as well on how much the total requirements are and how many pods you want running on a single node, and then calculate your node size accordingly.
Just to add, just to, sorry. Yeah, just to add, I think as a developer, he doesn't want to have he doesn't want to take the headache of how much nodes or what, he just want to deploy his application. So I'm not saying that AK is not a good solution, but he can go for web apps as well. So web apps is a good way to deploy your application. It's a serverless. You need not worry about your nodes. There is no AKS there. You need not worry. It's a default provisioning by Azure, and you can deploy your Java, Python, or any language or any artifact on web apps, and you can also expose the APIs as well. Just a suggestion.
Yeah, thank you. That's another suggestion as well. And based on your needs, AKS automatic could work for you as well, where you deploy your pods and we scale the underlying infrastructure for you.
That wasn't my question. My question was, is there a way to reserve the instance for a particular application? If I know for certain that I require these so my point is, if I know for certain that I require 5 nodes or pods, right? In that scenario, can I reduce the cost, or this is going to be same for me?
So are you asking about Azure reserved instances?
Yeah, that's correct.
Yeah.
I mean, is there a way which we are not aware of? I mean, as a user, see, there are different offering from Azure side. If we commit, for example, for PaaS services, like we talk about the Cosmos DB and all. If I commit that, I'm going to use 1 lakh RUs for a year, so then I can have a certain discount on that. If I commit something to Azure that I'm going to use these 5 ports for 24/7, is there a way to have some
Yes,
discount?
you can reserve
That was my question,
SKUs
yeah.
in certain regions. And you get discounted pricing for however long you reserve them for and how many you reserve.
Yeah, thank you.
3 years, then 5 years, we do it. It's 2 years, 3 years, the 5 years. It reduces 80% of your cost from the current what you're using, and of course you have to pay for the entire 3 years or 5 years, whatever. Yeah.
That's the AKS expert in the house. Any other questions? All right, thank you so much for attending today. We are all going to be available at the booth at KubeCon as well. If you have any follow-up questions, do stop by. Thank you.